And then Josh, you were asking about a question like number 2 from the homework quiz. I'm not positive I've received all of those, so I don't want to answer this one specifically, but let's do one from worksheet 1, and we'll just answer it with all solutions part. Does that sound okay?
Yeah.
Okay. Because these worksheet 1 problems are pretty similar, right? Okay. Let me grab all of those. And let's do maybe this one here, number 2, looks pretty similar. And we'll do this for all solutions, though, rather than on this interval here. Does that meet with your approval? Okay, so we're going to do it on this interval. This is all solutions. So the first thing we'd have to do is we got to get everything onto one side. So I'm going to subtract the tangent over, and then I'm going to factor out the tangent because I have tangents in 2 pieces there.
This is chapter 5, worksheet 1, correct?
Correct. Yes. And now that it's in a factored form, I can apply the zero product property and set each piece equal to 0.
Mr. Kulik?
Yeah.
Can you share your screen?
Oh my goodness. Thank you. Yes, I'd be happy to.
Thank you.
Yeah, Josh, I'm sorry. That's probably pretty much impossible to follow what I'm doing if you can't see what I'm writing down, huh? All right. So 1, and the directions say 0 to 2 pi, but we're going to do all solutions. I'm going to answer this question along the way to writing out all solutions. So to kind of do one, I'm going to need to do the other. So it's not a big deal. So I started by just taking this equation and making it equal to 0. So I subtracted the tangent x onto both sides, or from both sides to get everything on one side. And then I factored out a tangent because each of these terms has a factor of tangent in it. And now that it's in a factored form, I can apply the zero product property and take each of the factors and set them equal to 0 and solve them separately. So here, x is equal to tan inverse of 0. For this one, I'm going to have to add 1 to both sides and then square root both sides. When I square root it both sides, I get a plus or minus, and the square root of 1 is just 1. So this is going to break up into sine inverse of -1 and sine inverse of +1.
Wait a minute.
Okay.
So you did subtract the tan x from the other side of the equals, right?
Mm-hmm. Correct.
Which would put both of them at 0, right?
What do you mean by both of them?
Wouldn't it just be sine x, not sine x, sine squared x equals 0?
No, because let me draw an analogy that'll be a little bit easier to see what's going on. Let's say we have xy is equal to x. If I subtract x from both sides, I can't subtract x from xy. They're not like terms, so I'd have to write something like this.
Got it.
Same idea here. Sine squared times tangent x is not the same thing as like, because there's a variable with the sine squared, it's not like it's just a coefficient.
And you wouldn't divide tan x off of the sine x and get 1 on that side?
So if you do that, you're going to lose all the solutions here that come from when tangent is equal to 0, which I saw lots of you guys did on the homework quiz. So you don't want to do the division because you're really losing solutions when you do that. Right? It should be easy to see that if tangent is 0, then you have a solution, right? Because anything times 0 is equal to 0. So those are solutions. You'd lose those if you had elected to do that as your first step. So you don't want to do that.
How'd you get -1? And why is the 10x on the outside?
So this is like, again, think about this problem here. I could factor off a greatest common factor of x. Right? Okay to do that? Same idea here. It's just like tangent is my x and sine squared is like my y. So it's just I'm taking a greatest common factor of tangent x. It's not a reassuring sigh there. Does that make sense? Do I need to explain it a different way? Okay. So can I continue? Are we okay to move forward, Josh, or do you still... Okay. You let me know if we can...
I'm actually just writing that last part down real quick.
Yeah, that's perfectly fine. What I'm going to do here is I'm going to go to the unit circle and find the places where tangent inverse is equal to 0, where sine inverse is equal to -1, and where sine inverse is equal to +1. So I'm just going to go and look at the unit circle here for a second. Where did you go? There you are. Okay. So tangent again is y over x. So tangent is 0 when the y coordinate is 0. So that happens here at 0 and at pi. Sine is -1 when the y coordinate is -1. That happens at 3 pi over 2. And sine is +1 when the y coordinate is +1. That happens at pi over 2. So let's just go and record that.
Can you explain that again, please? Thank you.
Sure. So tangent on the unit circle is equal to y over x.
Never mind, I think I got it.
Oh, okay.
Right, it's -1.
Oh.
Y. Sine is y.
Sorry, yeah.
So then pi over 2. Okay.
Yeah, I'm sorry. I wrote down that wrong thing. Y over x is going to give me zeros at... Oh, 0 and pi. Yeah, okay, sorry. Yeah. So I wrote that all down correctly. Yes. Okay, so this looks like we're done, right? Not so fast. This problem is a little bit special. And in particular, tangent we have to be careful with. Why do we have to be careful about tangent? And really this is, you have to be careful about everything other than sine and cosine. If you think back to what the graph of tangent looks like, it has an asymptote in it, right? Remember, the graph kind of looks like that, where it has these asymptotes. That means that there's values for tangent that are undefined, right? So I have to double check here and see if these answers for sine are places that make tangent undefined, because if they are, that makes those solutions extraneous, and I would not want to list them. I need to discard them. Remember last year when you were solving rational equations? You had to be careful when you got your solutions to make sure you went back and plugged them in to make sure they didn't give you a 0 denominator. You guys remember doing that last year in your Algebra 3-4 class? The same idea here. Because tangent can be undefined, we have to worry about that. So to look at that, I'm going to go back to my unit circle. So tangent is going to be undefined when the x-coordinate is 0. Again, tangent is y over x. If the denominator of your fraction is 0, that's undefined. So that happens here and here, right?
Why?
So tangent is y over x.
Right.
So tangent of pi over 2 would be 1 over 0. That's undefined. Because you're dividing by 0.
Why would say
1 over 0 is undefined, right? So this happens at pi over 2 and 3 pi over 2, which means that these two answers are actually extraneous. They should be discarded. So our only solutions here are at 0 and pi. So that's our answer if we're talking about from 0 to 2 pi. If we're talking about negative infinity to positive infinity, or all solutions, we just tack on plus 2 pi k onto each of these. Because we want that solution and everything that's coterminal to it. Remember, coterminal is where we go once more around the circle, which is the same as adding 2 pi. Now you'll notice here that this we can actually condense down, because if one solution is at 0, the next one's at pi, the next one would be at 2 pi, and then 3 pi and 4 pi. So you could really condense this down to just be every 1 pi, and that would be okay also. So you could list it this way, or you could list this way. Either one of those would be okay.
Mr. Kulik?
Yes, Dan?
Sorry, but could you explain like the extraneous solutions part again?
Yeah. So you remember back when you solved like, oh dear, like 1 over x plus 1 plus 1 over x plus 2 equals 1 over x plus 3, or something like this. You solved rational equations like this last year.
Yeah.
You had to make sure that when you got done, you had to check your answer to make sure that you didn't get a 0 in any of your denominators. So like if you got a solution of -1, -2, or -3, you had to discard that solution because it would make this equation undefined rather than both sides equal, right? You remember that?
Yeah.
Okay. That's the same thing we're doing here. The issue is that tangent can become undefined because it's equal to y over x. The x-coordinate can be 0. So we have to be cautious that the other solutions we're getting aren't going to make tangent undefined. So that's all I did, is I went to the unit circle and looked for the place where the x-coordinate was going to be 0. That was these two values, which are actually the same as my solutions from the sine part. So I do need to discard them because rather than making the equation equal, it's going to make it undefined. So the only time you need to worry about that is if you have tangent, cotangent, secant, or cosecant in your equation with another trig function. But number 3, you don't have to worry about it because you have only tangents. Number 1, you'd have to worry about it because you have both tangents and cosines. You'd have to check for extraneous there. 4, you would not have to because you have only sines. 5, you don't have to because you have only sines. 6, you wouldn't have to because you have only sines. Similarly with 7 and with 8. Right? So there, you can't get extraneous solutions from those sorts of things.
Okay, so like if you get an x equals 0 for like your tangent.
So you're just looking at where tangent is undefined. So maybe the better way of doing this would have been just to take these answers and see what you get when you evaluate tangent of those. That's maybe the more clear way of thinking about it.
Okay.
So like if I take this solution and I do tangent of it, I get undefined, right?
Yeah.
So I discard it.
Oh, okay.
When I take this solution, I evaluate tangent for that. I also get undefined, so I discard that one.
Okay.
So that's maybe. Go ahead.
So what would your overall answer just be like x equals 0 and pi?
Correct.
Okay.
Yes, correct.
Thank you.
You're welcome. So Josh, the takeaway here was to translate from like a solution 0 to pi or 0 to 2 pi into a infinitely many solution situation. All you're really talking about doing is adding this little part to the end of the solution. That's all that needs to be done differently. So all the solutions you get for 0 to 2 pi, you just tack a plus 2 pi k on at the end of them. And there, now you've listed all the solutions from negative infinity to positive infinity, which I think was kind of where this question kind of originated, right? Okay. Follow-ups on this? If not, I'm happy to take other questions from the review or other homework assignments or general stuff or kind of wherever we're at. Happy to do more. That's really all I have planned for today, is to just deal with some of your guys' questions.
Could you do number 8 on worksheet 1, please?
Sure. Okay. So this is the first thing you'd want to do is to try to get the x by itself. So really we're going to take the cosine inverse of both sides. And if I go to the unit circle, the cosine inverse of 1, the places where cosine can give me 1, is at 0, and then everything coterminal to it, right? But remember that the range for sine is -1 to +1. So of those infinitely many solutions, the only one I can get is 0. That could be the only possible output of sine. Okay with that? So like negative
Yeah.
2 pi doesn't work. That's too small. Positive 2 pi doesn't work. Anything bigger or smaller than those don't work. 0 is really the only thing I can get.
Okay.
And then we can do sine inverse of 0. And that happens at pi over 2 and 3 pi over 2. So since it wants all the values, you just tack on your 2 pi k's. Or again, this is one where you'd notice that, hey, these are really just pi apart. So we could condense this down into a single one using a plus pi k instead of 2 pi k, but you don't need to do that if you missed that. Like, that's not a big deal to me. Does that feel okay, Jesse?
Yeah.
Okay.
Thank you.
You're welcome. Any others? Again, happy to do some more.
Mr. Kulik, could you do number 7, please?
On the same sheet?
Yeah,
Okay.
thank you.
All right. So if I look at number 7, this looks to me a lot like a quadratic. So imagine we had like 3. Why did it go? Why is it disappearing? Ugh. Imagine we had like 3y squared, or sorry, 2y squared plus 3y equals 2. You see how this, what we have there is basically the same thing, but instead of y's, we have sine x's, right? So I'm going to solve this equation much in the same way I would be solving this one. So I would start by getting it equal to 0. So I'm going to subtract 2 from both sides. And then we could either factor or use the quadratic formula. For the sake of argument, let's factor this since it is factorable. So I would need the two numbers that multiply to give me the leading coefficient times the constant term, and then add to give me that null term. So those are 4 and negative 1. So then I write out my factors. Greatest common factor from the first group. Greatest common factor from the second group. And then they both have a y plus 2 in common. So this one is going to factor the exact same way. Is that so far okay, Amanda?
Yeah, thank you. That's what I was missing. Yeah.
Oh, you're good to finish
And
it
then
from
you
here?
just set them equal to 0 and like
Mm-hmm.
move it over, right?
Yeah, and this one's even
Yeah.
easy because sine can't give you negative 2, so there are no solutions even coming from that
Okay.
part. So it's even
Yeah.
easier than that. You only really have to worry about the one piece.
Okay, thank you.
Yeah, you're welcome, Amanda. Happy to do some more. Again, if anybody wants to do some more, happy to do more. They can be from the review, they can be from the homeworks, they can be from the worksheets. I think all of that's up there, and I have keys, I think, up for all of those things as well. So you should have a little bit of, a fairly decent idea of what are the things that are like, oh, I did not get that, that we can talk about. But I'm happy to do as much as you guys want to do. Okay, then. If there aren't any other questions, I'm going to end class then for today. I'm not going to end up starting anything from Chapter 6 today. It certainly appears to me that you guys have enough work to do here with Chapter 5 that I don't need to start anything new today. That seems unnecessary. I do want to say one thing real quick before we go, and it's in regard to the homework quizzes. And I was a little bit disappointed by let's say it looked like there was some apparent dishonesty going on with the homework quizzes, where people were using identities that they had no reasonable reason that they would to know they existed. And I know that I'm here and you're at home and I can't see what you're doing. But oftentimes your answers are obvious enough that I can tell that like you didn't come up with this by yourself. So please be honest, do your own work. Don't Google things, don't look things up, especially that are supposed to be in these test and quiz settings. So I just needed to say that here before the test here on Thursday, that I don't want any cause to have to take things any further. We're just going to chalk this one up to not being clear enough with the directions. But I do want you to know that that was a little disappointing for me. So the test is Thursday. How this will work, you should come for the Zoom call. While you're doing the test, I'd like you to stay on the Zoom call in case there's any issues with the test that or any clarifications I need to make, so I'm able to do that. But you'll get an email from me at the start of class with the test as an attachment in it as a OneNote file. You can either do your work on a separate sheet of paper or you can do it in OneNote. You'll make a PDF of your work and then you'll submit that in a Dropbox on PowerSchool, just like we've done for the homework quizzes. So it'll be very similar, except instead of pulling from the content library, you'll have it in an email that'll come to you at the start of class. Is there any questions about that?
I have a question about like the next chapter. Are we gonna start it next week?
Yeah. And we'll see what we get through. And I'll talk to Mr. Stan and figure out where he's at, and we'll decide on an ending point. I don't know that there's no final exam. Whether we finish chapter 6 this semester or do it next semester, I'm not entirely certain of that. And I wish I had a better answer for you right now, Dan, but I haven't talked to Mr. Stan and find out where he's at in his class. We were pretty close for a while. I think we've fallen a little bit behind, but we'll figure it out.
So you don't know?
No final exam?
We're not going to have a final exam. With doing this from home, it doesn't seem very reasonable to give something that's that's weighted that way, given all this that's going on. So we're not going to do that. So I'll let you know once I've kind of figured out how the semester is going to wrap. But everything going on, it's still a little up in the air for me as to what the semester end is going to look like for us. But we're going to start chapter 6 next week, and it might be one of those things like we'll just take a little test over whatever we've been able to get through. If we're not able to get through the whole thing, and that'll be the end of the semester, is probably where I'm leaning. If we don't finish chapter 6 in the whatever couple of weeks that we have. 2 weeks left, I think, after next week, or after this, starting next week. So yeah, is that close enough to an answer for you? I know that wasn't very certain, but I think it's the best I can give you right now. So yeah, if you guys don't have anything else for me, you're free to go. Just make sure before you leave that you type bye into the chat for attendance purposes.